Today we will continue the modeling techniques in ADA from the last session. The other option that I want to point out today is that the mask and unmask option. Sometimes your model is too big and normally you want to mask some of the models to see the background or what's going on under the specific member. So in ADA you have the opportunity to mask that member and hide it from the view. For example, I'm going to give you an example. Let's say I want to mask these two members here. So you can always select the member with Control, and if you press the M button or you have the mask here, as you see, these members will be masked like this and the other ones will be hidden. So you can just work on this part of your model. To bring all back, you can unmask them or push D to bring all back. So if you want to work on just these four members, you select them, hit mask, and you can work on these members. Also, we have the option of inverting our selection. For example, you can select these and hit I and go here and invert selection, as you see, or Control I. All of these the selections will be inverted, and right now you can mask that member and keep the other one. So you have two ways to mask your member or your element to work on. This is the mask option in ADA. Okay. So we have another helpful option also to working with elements or selection. We call it a selection tool, and as you see here, we can create our own selections, and it will help you to separate the, let's say in a structure or in a building, the beams or columns or braces according to specific selections and names, and you can work on them separately or see the results separately. So here for an example, I'm going to separate or build a selection for these four upper members. To build a selection, firstly we need to select the members with the window, and you can go to Edit, Select, and create a selection, or Control L. And here, as you see, AD is asking a name for your selection. So I'm going to type up, and you can even here assign a color to your selection to emphasize it better in your model. Right now I'm just putting it now, and okay, so right now I have a selection with this name, and to bring up this selection or select it, you can hit Control K or Edit, Select, choose a selection. So as you see here, I have the up selection here, okay, and they are automatically selected. So this is how we define our selections in ADA, and as I already explained, Control K can bring it up, okay, and putting mask will mask it, and you will be able to see this separately. This is how we create selections in ADA. Okay, so I'm going to bring these up. Okay, so there is another way to select the specific entities in your model. Of course, you have these the default selections in ADA. For example, beams. If you push this, it will select all of these horizontal beams. And in the case of columns, I'm going to add some columns to my model here. Okay, and here, and here, and here. So, for example, if you want to select the columns, ADA has this default selection as columns, and as you see, it will automatically select the vertical ones. These two are not vertical; they are aligned, and so completely not aligned with our vertical global axis, so they are not columns. And also slope members, if you want, you can use this to select those kind of members. And we have triangular plates, rectangular plates, horizontal floors, and other automatic selections here. You can even select them with their usage, what kind of usage they have. We are going to discuss about this in next sessions. But another useful way to select your members, let's say I'm going to define my members, the new column members. As and Control H, and I'm going to define these, replace as, let's say, in HSS. Okay, square HSS, and let's say HS400616. Okay, as you see, all are selected. And okay, so here we have the HSS as our columns. So I want to show you how to select these members using the spreadsheet. So the easiest way is in the member activation, just activate your member selection. Control H, bring up the spreadsheet of members. You can select your member here depending on what type or what kind of characteristics you want. For example, let's say I just want to select the HS sections. So what can I do is like this. Just select this for here, and okay. As you see, the only HS sections in my model are selected. So this is a very effective way to select different entities or characteristics. Or for example, let's say if I had some members with different end conditions, I could have selected from here, and I just can say that, okay, the members that have one end hinge and other end fixed, they are going to be selected just like here. So this will help you to navigate between your members and select the specific member that you're looking for. And also, as you see here, if I bring up the spreadsheet again, ADA has this option to sort your members depending on each one of these categories. For example, if I want to sort with their names. You just click here, and as you see, they're sorted like this, and you can pick up whatever member you want, or you can sort them like this by just double clicking or right click and sort up or sort down. So this is also very helpful when you have so many members and you want to sort them depending on whatever characteristics or properties you want. Okay, so this was the selection using the spreadsheet. Okay, the other option that I'm going to discuss here, most of the time we want to separate or split a member. So instead of just putting nodes or adding nodes one by one or drawing members one by one, IDA has this option to split the member. So what can I do here is select the member that you want to split and go to here. We have two options: split at what coordinate on the member you want, or split for equal distances. So here, for example, I want to split my member to 5 equal parts or sections. So I just put here OK. Normally we put the check mark here, yes, because this option is for if you have defined any load on this, the load will be divided also with this division, so you will have the load. So to do this, we need to first save our model. For example, here I have the advanced one, so save it, yes. And as you see here, it is divided or split to 5 members. And also to use the other one, the other command here, you can select the member, click split, and you can click on the member to split it. For example, you have here the distance that you want the member to be split. Let's say I want to split it at 3. So I just gonna put 3 here with the mouse. Oops. 302, 3. Okay. And as you see, there's a node there, 301. Okay. And we can even change it to 3. Okay. And hit OK. Yes, as you see here, ADA has splitted my member to 3 and 2 meter lengths linear members. So this is another way to split your member. And to join members also, we have the join option or join command here. For example, if I want to join these 2 members as one, I can use this option here. As you see, join. Yes, okay. So these 2 members are already joined. So you have the option to split a member or join it. Also, we have another very useful option that is normally used in defining the braces. For example, let's say I am gonna put 2 braces here linear like this, add from this node to this node, and from this node to this node. I'm going to change these two for an L. Just select those, Control H, and here I'm going to replace them with an L section. Here, T equals B. Let's say 219. Okay. So as you see, I have my braces like this, L section, and if you check out, you will see that they are not well oriented. So I'm going to use our beta angle to orient the braces. So if you see here, they're not well oriented. So what can I do is that select this and go to the properties, beta angle, and rotate it for 90 degrees. There you go. So I have my member here. Rotate it for 90 degrees, and this one also same, Control E, and 90 degrees. You can also do this for other members to rotate them. And the helpful option that we have here for braces, if you want to put a note here automatically, I mean between this intersection, you just click your braces and you can go here. This one will add a pin connection between the braces, and this one will be a rigid connection. So in this case, we want a pin. Just click it, split along with loads, OK, and as you see, we have the new note here. OK. Okay, to check the end conditions of the braces, you can always select the member and double click. So as you see here, the end connection of the brace is already pinned. If you want to view it in the model, as we already discussed, you go to Options, Attributes, and here End Conditions, you activate it. Okay. Okay, as you see, here we have the end conditions. Okay, so this was how to put a node in a bracing, intersection of two braces. So you can do it automatically with these or these two options, commands in the ADA. Okay, the next topic that I'm going to mention today is the loadings, how to put loads, define load cases, or load combinations in ADA. So To define load cases, we need to go to this, as you see, the menu, load and load cases definition. As you see, there's an already defined dead load in ADA, which is default of ADA, and it's automatically calculated for each member. For example, if I click this member, as you see, I have the dead here, and it is automatically calculated. So I'm going to have that dead load case on all of my members, unless you deactivate it like this. Double click the member, and here put it now. So this member will not have any dead load. You also have the opportunity to define other load case names here if you want to put the self weight on other load cases. So for now, I'm going to leave it as dead load. Okay. And here in loads, load cases definition, you can always add the new load cases. For example, I'm going to add a live load. So it depends on your code, because as you see, these types will be used afterwards on defining the load combinations. So you can always follow the specific code if you're planning to define automatic load combinations. So in this case, I'm going to use NBC 2010, and my load is a live load. So it will be used in load combination generator. So as you see here, we have defined a new load case as live load. And you can add also other kind of loads here. For example, I'm going to add snow. You can always go here, 2010, you have a snow. You have wind, you can define wind. And other kind of loads that you may have in your project. So I press OK. Those load cases are generated. And now we can apply those loads on the structure. So here, to make my model a bit simpler, I'm going to delete these extra members. And to select these extra nodes, you can always go to Edit, select Inactive Nodes, and hit Delete. All of them will be gone. So I'm going to make my model a bit three-dimensional to add extra load. So I'm going to remove my brace, join the members. Okay, and also this one, I'm going to join them. Okay, delete this node. Okay, because I have supports at the bottom, I'm going to define these two nodes as hinge or normal. Place with normal. Okay. So, and for all of the members, I'm going to define them as fixed end conditions. So, as you see here, they are all hinge. So I'm going to replace them with fixed. Okay. So to show you how to apply also loadings on two-dimensional or roof elements, I'm going to build my model as roof. So select the nodes, Control C, and on Z I'm going to define it as 5 meters, Control V, and add 2 members or beams here to form my frame. And I'm going to add a floor member to my model. Add and click the this is the floor element, and to view the load distribution of the member on the roof, you can always go to view options, O, and here in the floors part of this dialog box you can have the local axis system activated, or you can have one-way or two-way symbol. So I'm going to define my floor as two-way slab, so I'm going to hit this, apply OK, and if you double click it, it is already in two-way, so we are OK. Here you can define the self-weight of the roof and the load case number. So for example, for this roof I'm going to apply its dead or self load to the dead load case, and let's say put it as 5 kilopascals. Okay, so we have already defined the load cases. To apply the loads to the structure, you need to go to the loading mode or load case mode. You need to activate this mode. As you see here, we have different modes, and we will discuss about all modes here. The first one is the structural mode that we build our model on it. If you want to modify the model, delete or add some members to model, you need to be always on the structure mode. And if you want to work with loads, add loads, remove loads, or check loads, you need to be in this mode, load case mode. Okay, so I'm going to click this, and as you see, we have the already defined load cases, the dead, live, snow and wind. So I'm going to check first for the dead loads. So I pick that, save the project, and as you see here, ADA is showing the dead loads, or in this case the self-load, self-weight of the structure. The diagram is too large to diminish it or to normalize it. You just click here and ADA will automatically adjust the size of the diagram. And as you see here, I have 5 kilopascals on my floor, and the green ones that you see here, these are the self-weight, kilonewton per meter, for the beams and columns, the linear elements. So these are all my dead loads, and they are automatically applied with ADA. But if we want to add manual loads, for example, to a specific load case, let's say to my live load, I want to add 1 kilonewton per square meter of load. To do that, you need to go to load case mode, select your load case, that in this case I want to add in live load, and select your roof. So the roof is already selected here, double click. As you see, I have this dialog box here. This dialog box is this dialog box will help me to add the loads, distributed, concentrated, or even temperature loads on my floor. So in this case, I want to add a distributed load to my floor. So just click this plus here, add a new row, and you will insert intensity of the distributed load in these cells. So I'm going to put 1 kilopascal for each one. So I'm going to add a 1 kilopascal of distributed load to this floor in live load case. Okay, and it's done. As you see, ADA shows that the live load is applied here. Or for example, I can add my wind load to one of these members. For example, let's say I'm going to select these two members, Control H, and you have the options of distributed, concentrated, torsion, temperature, or even shrinkage to these members. So because the wind load will be a triangular, I'm going to define a triangular distributed load on these two members. So I'm going to add one here. To do that, we need to select the members one by one. Sorry. So I'm going to select this, add, and here is the load intensity for start and end of the member. So start will be, let's say, 0.5 kilonewton, for example, and the end will be, let's say, 2 kilonewton per meter. Okay. Okay, we need to define also the projection. So the projection will be to strong axis like this. So as you see, this is the wind load applied to this member, and we can do the same for the other one. Again, 0.5 to strong axis. Okay. As you see, we have defined the wind load case like this, and you can have other loads, any type of load on your members. You can add concentrated, as you see here, temperature, or even torsional load. Okay, next step is to define the load combinations. So as you see here in the loads menu, load cases, we had defined all load cases here, and as you see here, dead load will be automatically calculated, and we don't have any live load reduction yet. So but you can define your tributary area or overload or reduction. We are not going to use it right now. Dynamic load, ice, or temperature. You can define all of these loads on your model. So right now for this model, we just defined 4. And the next step is to define the load combinations. So to do that, we go to loads menu, load combination, and definitions. Here, you can define your load combinations manually just by clicking plus here, name, and other characteristics. And in this tab, you can define the load factors. But ADA has a load combination generator, which is very useful and very interactive. You can always use it for your models. The first step is to select your code. For example, in this case, we have used NVC 2010. Here, as you see, we have different options to define the combinations, generate an unfactored load combination per load case. You have this option. You can generate with seismic loads acting towards the positive direction only one side. You can generate a specific load combination for your mass. Here we have we can include the spectral envelopes and time history envelopes into our load combinations, and these are other options that you have here. For example, if you have already some load combinations, you can add these new ones to them or delete the previous ones. So for now, this window is okay. We push next here, and here you see the load combinations that ADA will define according to that specific code, NVC 2010. And I'm going to activate the wind also, so our wind load cases will be defined also. And if you have moving loads or press stressing and shrinkage, you can always define also those load combinations, which we will discuss all of this in next sessions. So for now, I'm going to leave this dialog box like this. Hit next, and you see these are all load combinations that ADA will automatically generate for this model. Just hit finish, and as you see, we have around 30 load combinations, ultimate and service, and even an instances deflection already defined, and you can check each one, the load factors here, or you can even modify them. You see the load factors of each load combinations here in this window. So let's say for 1.4 dead, as you see, the factor is 1.4, and other load combinations defined as well. So we have our load combinations here. I just put OK. So right now I have defined my structure. I have my supports here, the members, the floor, everything is defined. I have my load cases, load combinations. So we can do the analysis right now to get the internal forces in the structure. But in order to prevent any kind of error or mistake in the model, ADA provides a tool here as checking the model. Of course, you need to be in structure mode, and in the tools menu you have checking the model. If I press this, ADA will start to check all of the nodes, the geometry, the selections, everything in the model to see if something is missing or you have undefined geometry, undefined material. So it's very useful. I'm going to use this tool here, okay, and ADA mentions that, okay, all nodes are connected and members are connected to them. So as you see, there are no errors on my model, so we can proceed to analysis phase. To do the static analysis, we are going to use this icon, as you see, static analysis, and hit that. ADA will start analysis, and here it's showing that, okay, number of load cases is 4 and load combinations are 30. It shows you the number of members in model, number of nodes, and if you press analyze, it starts analyzing, and as you see, all of the load combinations are defined, are calculated, and hitting close, you have the results here. So to see the results, we need to go here to the load combination mode. If I click here, I will have in this drop down menu or drop down list, I will have all my load combinations here with their results. And to check the results, we are coming back again to our view options. And as you here see, we have a results tab here. In results tab, you can select what kind of results on members or supports or nodes you want to check. For example, in this case, I'm going to check for my MX results on the members and apply. Okay, and as you see, you have some diagrams here. If they are too small, just use the ADA's automatic adjustment tool. So as you see here, I have my MX, my beams, and you can always increase or decrease the size of your diagram. And as you see here, because I had some hinges here, my moment is 0 here on this member, but here it's fixed. So this is the MX or moment around my strong axis. So to see the values, again, you can use options menu, results, and just put the check marker on this square like numerical, and OK. So here you will see the values, and your units are here. So it's kilonewton meters. So you can consult all of the results here. For example, again, I press O. Let's say we want to see the shear Vy in Y direction and numerical. Apply. OK, and as you see here, this is my shear diagram. Shear diagram and the values. Options. My is the moment around the weak axis. And all of these results that you're seeing right now is for this load combination 1D. So let's say if you want to check your MX for ULS201, you can do always like this. So you need to select your combination first, and after that you hit O and select what kind of diagram you want to check. Vx is the shear for X direction, and Z is the axial load or axial force, as you see here. And also you have the deflections. So if you check mark it here, deflections around strong axis. Okay, you will see the deflection of the structure here. For example, here I have minus 10 millimeters on this beam. And you can always decrease and increase the size of the diagram or the scale. And here you can change the load combinations that you're checking the results. Okay, this was how we check the diagrams or results on members. And also you can check the results from supports. For example, if you want to know the reactions in supports, you can always use this part of this dialog box. So let's say I want to know the RY on my supports, RY reaction. So put the check mark here and here to see the values. Okay, and as you see here, I have my reactions here. You have the option to double click on the node to see all of the reactions. So to do that, you need to select the supports and double click on the support. So here it's the results for this load combination, and these are the reactions Rx, Ry, Rz, Mx, My, and Mz. So it can be either on global system or local system. So right now, because they're same, we have the same results here. And you have the displacement here, displacements of the supports, that in this case they are all 0 because you have fixed supports. In case of elastic supports, you will have some deflections here. Okay, and also you have the same option for to check the diagrams or internal forces in the members. So let's say if you want to see all of the internal forces in this member, you just click on the member selection, double click on the member, and here you are. You have all of the internal forces in this member, the shape of member, the position, the position of the force, or the position of the diagram on along the member, and here is your Mx, Vy, My, Vx, and other internal, and even you have here the deflection, the axial deflection, strong axis deflection, and weak axis deflection. So you have all of the results as spreadsheets here. Okay, so this was how we define a simple model in ADA, build the model, define the sections, define the load cases, load combination, and do a simple static analysis, and how to view the internal forces and diagrams. This concludes our session on basic analysis on ADA. I hope it was helpful for you, and you can always contact us. As you see here, we have our tech support already always available. If you have any questions or any problems with modeling, just send us an email to this address. We will be very happy to help you to solve the problem. Thank you very much, and hope you enjoyed this session.